Hello and welcome to my talk on Sequels-K, a bidirectional Swift Kotlin Twinspiler. I'd like to start with a short live demo, therefore I switch to Android Studio and I switch to the Android emulator. And here is an example app, a board game, and I can play checkers with this game. I play white and the AI opponent plays black. I have to capture this piece now, and I won't finish this game. I just wanted to show that it works. I've opened a small part of the source code. Here is the class checkers game logic, which yes, consists of the game logic of this game. I have, for example, a method like get initial board that gives the initial position before the game starts. I have methods get moves that are responsible for determining the Z of allowed moves, so that the white player can only perform allowed moves and the AI opponent can only choose among allowed moves. And last but not least, there is a method called evaluate board that assigns for each position a value, and the AI uses this value to determine a good move. I won't go into the details of this source code. The interesting thing is that I did not write this source code, and actually no human being wrote this source code, but it has been automatically generated. It has been transpiled from Swift. Why is this interesting? I switch back to my presentation. Today, Android and iOS have more than 99% market share. And if I develop an app, I cannot neglect Android because then I would neglect more than 80% market share, so I can't do this. And neither can I neglect iOS because there's much more purchasing power behind it than Android, so typically I won't neglect it as well. So to sum up, usually I have to develop an app for both platforms. I can do this natively, though both platforms offer SDKs to develop for the respective platform. They offer similar features, but different APIs, and I need different programming languages. Therefore, if I develop apps for both platforms natively, I have two code bases in high development effort and high maintenance effort. Therefore, there are a lot of cross-platform development frameworks around that want to reduce this development effort. And the technical details are quite different, but the idea is always the same, namely using only one shared code base and then in some way to derive apps for Android and iOS. So I won't go into the details of all these different frameworks. The idea is good. There are advantages, of course, but there are also possible disadvantages. For example, a high dependence on the used framework. So for example, if Android, there's a new feature in a new Android version and the used development framework, cross-platform development framework, does not support this new feature, you might get into trouble because you can't integrate this new feature into your app. And due to these disadvantages, I'd like to propose a new approach that is based on native development. So if you want, we go one step back and have a closer look at native development. And I refer to the board game as an example, as already shown. So if I develop an app natively, I usually apply some sort of model view controller design pattern. I want to review this in case of this board game example. So the model usually includes the business logic. This is the case in my example as well. So the model consists of, for example, the state of the board, but also the game logic, the algorithm for the AI, all this stuff belongs to the model. So in many cases, the model is the most complex and most difficult part of an app. The view consists of the UI, For example, here one button for each square and a few other UI elements. The view might use some assets like images of the pieces in our examples, can be incorporated in the view. Last but not least, the controller acts as a broker between model and view. So, and if I develop the same app for iOS, I typically would apply a very similar architecture. I can reuse some assets. The images might be reusable. Apart from this, I have most of the work has to be done twice. At that point, the new idea comes in. I'd like to propose to transpile the model, including the business logic, in a bidirectional fashion. So I assume that the model for Android is written in Kotlin and the model for iOS is written in Swift, and I'd like to transpile the source codes from one direction to the other and the other way around. The question now is this difficult? How similar are these languages? I'd like to answer these questions, and to do this in a systematic way, I had a look at the official Swift documentation at the first chapter called Swift Tour, which gives a brief overview of the most frequently used and the most interesting Swift features. I extracted all language constructs out of this chapter and I put it into this table grouped by section of this original documentation, and then I had a look at each language construct. For example, to declare a variable. This can be done in the following way. We use the keyword var, and we can see that this code is identical in Kotlin. So this is an example for a language construct that is really identical in Swift and in Kotlin. So we have no effort at all if you want to transpile this code from one language to the other. There are some other language constructs that are identical as well. I marked them in the table. When we declare a constant, we use the following line of code, and here there is a difference. In Swift we use the keyword let, and in Kotlin we use the keyword val. So it's still very, very similar. It's only one different keyword. We could apply some simple string replacement to replace one keyword with the other one, and so it's very similar. I marked all language constructs that are very similar in this sense in the table. However, the majority of the language constructs can be transpiled, but it's more difficult than just doing a string replacement. I'd like to make one example, namely property observers. In Swift, there are special methods willThat and didThat. willThat is automatically called immediately before a property is assigned a new value, and didThat is called afterwards. And there is no willThat or didThat in Kotlin. However, the Swift code can be transpiled to Kotlin by using an own implementation of Zeta, which is allowed in Kotlin. And in this implementation, I would put first the code of willThat, then I would manually assign the new value to the backing field, and finally I would put the code of the didThat method. And of course, this can be generalized and can be fully automatically transpiled from Swift to Kotlin and the other way around. So this language construct is transpilable, but you need some effort to get this right. And this applies to most language constructs. Last but not least, there are a few more exotic language constructs that are very different, so that it's nearly impossible to transpile them. For example, in Swift you can overload a function by just applying different argument labels. You can't do this in Kotlin because Kotlin does not know the concept of argument labels, so you can't do this in Kotlin. But fortunately, only a few exotic language constructs are so different. To sum up, creating a bidirectional transpiler seems possible, but it's non-trivial. In the next step, I developed a bidirectional Swift Kotlin transpiler, and I named it sequels K. I developed it from scratch, and the parser and the lexer are generated using Antler, and the result is one consistent bidirectional transpiler. In the previous slides, I had already included some screenshots from the website, which an interactive website where the transpiler can be tested. You can test it yourself by just going to this URL. I want to give a short live demo at this point. Therefore, I switch to my browser. And I program a very simple class in Swift. I have one property and I add an initializer for this property, which, yes, initializes this property. So very simple use case. We see that in Kotlin it's quite nice. Kotlin has this special thing as a primary constructor, which is very short, very concise, and does the same thing as the Swift code. So we have a good transpilation result. The most interesting point is probably that this is a bidirectional transpiler. So I've written this code in Swift and transpiled to Kotlin. As a Kotlin programmer, I can use this code, but not only use this code, I can fix bugs and I can enhance the code without any problems. So, for example, I can just add another property in the Kotlin code, and this can be transpiled back to Swift so that the original programmer can use this enhanced code as well. So we see in the Swift, on the Swift side, we have this new property and the initializer as well. I switch back to my presentation. I did a case study using the board game, which I've already shown. And originally, I implemented this app for iOS, and I implemented two board games manually, namely Checkers and Reversi, using Swift, of course, including a Minimax algorithm for the AI opponent. Then I applied the transpiler to this Swift code, and 68% of the source code could be automatically transpiled. That is the model, including the business logic. In our case, the business logic is the game logic. And then I had to spend less than 2 hours of manual work to get a complete, fully running Android app. Basically, I had to add the UI and some glue code between UI and model. In the next step, I added a third board game, namely chess, to the Android version of the app. So I programmed the game logic of chess in Kotlin manually, and then I transpiled the model, including the game logic of all 3 games, back to Swift. And then I had to spend less than 5 minutes manual work to get to integrate the new game into the iOS app and to get a fully running chess app for iOS as well. Basically, I just had to add a third button to activate the new game. And all the difficult part has been automatically transpiled. This way, I can demonstrate that the approach can be useful and that the transpiler is useful as well at the current point. Future work. I've already started some sub-projects for the SequelsK project. For example, an abstraction layer for concurrency operations, or a plugin for Android Studio to allow the usage of the transpiler directly out of Android Studio. An analysis of similarities between unit test frameworks of Android and iOS in order to check whether it is reasonable to automatically transpile unit tests as well, and a comparison with existing unidirectional transpilers from Kotlin to Swift or the other way around. Furthermore, there are some further steps that are quite obvious, for example, the support of more language constructs. At the moment, I would say SQLSK is in the state of a working prototype, so a lot of language constructs are already supported, but there's still more work to do to support even more language constructs. And larger case studies would be nice. I think the board game example is a quite good example for the beginning, but it would be nice to have more examples. Thank you for your attention.